Hi, hello everyone. First of all, thanks for being here in my YouTube channel. Let's talk about types of DC motor and characteristics and application of DC motor, necessity of starter in DC motor, that is extra from your syllabus, right? So, as you can see the diagram, brushed DC motor, right? There is a field magnet to produce a magnetic field, constant, and there is an armature having armature slots to holding the armature conductor. Armature conductor, it carries a current, experience a force. And next there is a commutator. Commutator supply current to the armature conductor. And next there is a brushes. Brushes supply current to the commutator. So commutator is like a rectifier as well as inverter. Rectifier for generator, inverter is for motor, right? Next types of DC motor. One is separately excited. Another one is self-excited. In that self-excited, we have a shunt motor, series motor, and compound motor. Okay. In that compound, we have a short shunt and long shunt. Okay. So, motor which converts electrical to mechanical, everybody knows. In that separately excited, field winding is separated and then separate D supply is required to excite the field winding, right? And self-excited, whatever supply we are giving, right, from the input terminal VT. So that itself gives excitation to the field winding. Shunt field winding is parallel with the armature. Series field winding is series with the armature. Okay. Compound motor, it's a combination of shunt and series field winding. I mean shunt motor and series motor. In that we have a short shunt compound motor and long shunt compound motor. Okay, short shunt field winding is parallel with only armature. Here long shunt field winding is parallel with both armature as well as series field winding. Right. We'll discuss one by one. Before discussing, we'll see the internal circuit diagram of DC motor. Here there is a armature. Okay. So brushes will be there. And this one is armature resistance. This one is EB. Okay. This one is V terminal voltage. I'll just consider a shunt motor, okay, for your understanding purpose. This is RSH. This one is IL current and RA. This is IA current because current is flowing through the armature. And this one is ISH, right? So this is EB. And plus minus will be there. This one is an internal circuit diagram of DC motor. Okay. So how to determine IA? So IL is equal to IA plus ISH, right? So IA is equal to IL minus ISH, right? So this is the equation of armature current. What about EB or V terminal voltage? VT minus, I just apply a KVL. IA RA minus EB is equal to 0. So VT is equal to EB plus IA RA. One thing is there, just you add a brush contact drop because that is negligible when motor armature rotating, that time there is a spark occurs, I mean contact with the brush and as well as commutator. So just you add a brush contact drop, BCD, right? So this is the terminal voltage equation. Next, if you want to calculate ISH is equal to VT by RSH because this one is parallel circuit, right? Here also voltage same, here also voltage same. This voltage is common for both the branches. This is the internal circuit diagram, internal equations of DC motor. If you want to calculate output power, P is equal to EB into IA or mechanical power T into omega. Okay, we'll see separately excited DC motor. Okay, so separately excited field winding is separated from the armature, right? This is VF and this one is RF, this one is IF. Field winding is separated with armature. This is armature. Okay, this is EB. And this is RA, this is EB. And here we are giving V terminal voltage, here IL. And then whatever current is flowing, this is IA. So, if you want to calculate IA is equal to IL, right? And if you want to calculate EB or VT minus IA RA minus EB is equal to 0. Minus, you add here itself brush contact drop, okay? Minus V brush drop, that is. Because IARA drop will be there, brush drop also you add here is equal to 0. Finally, VT is equal to EB plus IARA plus VBCD, brush contact drop. What about IF? IF is equal to Ohm's law, VF by RF. What about power electrical? That is EB into IA. Just you can take EB from this equation. EB is equal to what? VT minus IARA minus VBCD. We'll discuss self-excited DC motor. One we have shunt, series, and another one is compound. Right? So here I'll discuss shunt and series. Shunt first. Field winding is parallel with armature. Okay. Here. This is armature resistance, and then this one is EB. So this one is IL, this one is IA, armature current flowing through this branch, and then this one is ISH, this one is RHS, shunt field winding resistance, V terminal voltage, this one. How to calculate IA? So from this equation, apply KCL. IL is equal to IA plus ISH. IA is equal to IL minus ISH. For generator, IA is equal to IL plus ISH. If you want to calculate EB, this is EB, this is RA. Okay. If you want to calculate EB, apply KVL for this loop. VT minus IARA minus EB minus V brush contact drop will be there. This contact drop while rotating motor will give spark. So is equal to 0. If you want to calculate EB, EB is equal to what? VT minus IARA minus VBCD. Right? This is the equation of EB. If you want to calculate mechanical power or electrical power is equal to EB into IA, mechanical power T into omega. What about ISH? ISH is equal to VT by RSH. Right? Next we'll see series motor. Field winding is series with motor. Okay. So this is armature having armature resistance and EB. Field winding is here, series with the armature, supply is VT, this direction, okay. For generator, this direction, opposite. So here ISC are here IA, and then this is RA, this is AB. So here the condition is IA is equal to IL is equal to ISC, right? And what about EB? I'll just apply loop equation, VT minus ISC RSC, right? Minus IARA minus EB minus VBCD, brush contact drop. If you want EB, EB is equal to VT minus ISC, RSC, I'll take IA and ISC as common. So IA I'll take, IA is into RA plus RSC, right, minus VBCD, right. And if you want to calculate power output, that is P is equal to EB into IA, right? And here same current is flowing, right? And input power, if you want to calculate, power is equal to VT into IL, okay? Here also same. Power input, if you want to calculate input power, VT into IL, right? Next, compound motor, short shunt, long shunt. Okay. So short shunt, it is a combination of both series field winding, shunt field winding. It is called as compound motor. Short shunt field winding is parallel with only armature. And whatever the current is IL, same ISC, and here ISH, here there is a IA current. So it is splitted here, okay. What about armature current? IL is equal to IA plus ISH, IA is equal to IL minus ISH, right. So if you want to calculate VB, I will be applying a loop equation for this one. VT minus ISC RSC minus IARA minus EB minus V brush contact drop is equal to 0. If you want to calculate EB is equal to VT minus ISC RSC minus IA RA. For series motor, IA and ISC same, but here it is junction is present, so it is not equal. So minus VBCD, right? And if you want to calculate mechanical power output, P is equal to EB into IA, right? PM is equal to T into omega. So I'll apply loop equation for this one like this: minus ISH RSH plus EB here plus, okay, plus IARA, not minus IARA, because opposite current here is equal to 0. Finally, we'll get EB plus IARA divided by RSH is equal to ISH. Right, this is the equation of shunt current. Next, long shunt. Okay, so long shunt field winding is parallel with both the combination of series field winding as well as armature. So this is series field winding, and this one is armature. Okay, and this is your V terminal voltage. For solving the problems we required. Okay, and this one is RA, this one is EB, right? ISH, IL. Here IA and ISC are same now. Okay, so what is the equation of IA? IL is equal to IA plus ISH, right? This is junction. Incoming current is equal to outgoing current. These two are outgoing. So IA is equal to IL minus ISH, right? So if you want to determine EB, I'll apply KVL this loop VT minus IA into ISC will take, okay, ISC, because IA is equal to ISC, right? Because same current is flowing here also ISC. So I'll take IA into this RA, this RSC, this RA series. So RA plus RSC minus EB minus V brush, okay, is equal to 0. Finally, we got EB is equal to VT minus IA is common outside, RA plus RSC minus V brush contact drop, right? This is EB. If you want to calculate power electrical, that is EB into IA, PM is equal to T into omega. ISH, how to calculate ISH? ISH is equal to what? Same voltage, right? VT is same for this branch and this branch, because there is no here inductance or resistance. So ISH is equal to VT by RSH, right? So this is the equation. Once again, see here, separately excited, field winding is separated, series motor and shunt motor, compound motor, combination of these two.